Thank you all for coming to this session. My name is Gary Flake. I run a group called Live Labs, and today we're going to talk about a different way of visualizing and interacting with the web. Now, before we get going in earnest, I want to give you a little bit of a background. Live Labs is a group that you probably haven't heard, but you may know some of our work. So we're responsible for things such as Sea-Dragon, Photosynth, many other smaller projects. Just humor me for a moment, a quick show of hands. Who here is familiar with either Deep Zoom or Sea-Dragon from a technology perspective? Okay, that's great. That will help me a lot in terms of how much context and background you need for what I'm going to talk about today. Now, for today, I'd like for you to keep one thing in the back of your mind. We are a lab. We sit between the R and the D. And what we try to do is basically pursue some higher risk activities that might be a little bit too applied for a research group and perhaps a little bit risky for a product group, but trying to find what is the compelling connection there. So as a result, everything that we do is an experiment, and our experiments really have two higher level goals. One, we hope that what we do is compelling and worthy of being included into a product. But that's not always the eventual route of everything that we do. The second outcome is if we do something that is high risk, where we learn from our mistakes. And today, I'm going to tell you about what is basically the most ambitious experiment that we've ever pursued within Live Labs. And hopefully, you'll be a part of it. So let me take a moment and step back to frame the overall things that we're going to talk about today. One of my favorite quotes, or actually it's more properly a paraphrase, is Frank Zappa, the late, somewhat eccentric but brilliant musician from the 1970s. He said something along the lines of, data is not information, information is not knowledge, knowledge is not wisdom. And it's this sort of split between the different levels of what we think about as things worthy of consuming that is the focus of much of the talk today. The web is full of data. There's some information. It's arguably kind of shy, lacking in knowledge, and I'm not sure that we've actually put much wisdom there as well. So keep that sort of philosophical framework in your mind over the course of this presentation, because I think it'll help direct you towards the things that we're really ultimately shooting for. Now, what we want to do is we want to rethink the web. So we're stepping back from it and we're saying, okay, what if you could step back and look at the web a little bit more holistically? If there was a way of actually interacting and seeing the forest instead of merely the trees? Are there patterns to be discovered? Are there things that you can do in terms of interacting with those patterns or jumping back and forth between them? With that, I'm now going to introduce to you, and this is, I don't know if you can see my t-shirt, but this is our logo for a new experiment called Pivot. Pivot is fundamentally more than anything else about visualizing information, revealing those hidden patterns, and then in a way that is joyful, powerful, compelling, and informative, being able to act on insights that you discover. It's going to be, I suspect, an application that is not quite like anything that you've seen before. You're going to draw similarities between many things that you have seen, but it's going to be an imperfect mapping. You might find it similar to a file explorer. You might see some similarity to how people navigate the web. You'll want to compare it to a search engine or even a spreadsheet or a database. It's something that really blurs the lines between what these well-established applications look like. And as such, it's doing something or a set of things that are both old and new. So for us, this means that Pivot has the potential of defining something that might be a new class of application. With that, let me get right into a demo. Now, I have to apologize right off the front. I think some of you may have noticed that the bandwidth today is somewhat lacking. And I'm sharing bandwidth with you. And so asking you to turn off your laptops isn't going to do a thing, because we're kind of competing with the thousands of other people outside of this room as well. But if necessary, I'm going to change my demo in real time to use local data. I think it's more compelling if I'm actually accessing data over the web. But keep in mind, the network pipe that I'm using right here is less than what you probably have at home. And so the experience might work or might not work as a result. So first, let me just show you by example some things that you can do with it. Suppose I'm looking for a dog. My kids are ready to get a dog. I have some constraints in terms of the sort of dog I'm looking for. So maybe I need a small dog. I'm not too sensitive to how popular they are, but man, I really want a very intelligent dog, a friendly dog, and a loyal dog. Maybe I live in an apartment, so it's hard for me to exercise my dogs, exercise a dog. So I'm going to pick in their minimal exercise. And then right away I see that there's a couple of candidates right here. Now what's really cool about this is that all of these images, all of these assets, all of this information are being streamed over the web. This is not locally cached. I could even do the sort of thing where, okay, let me remove those filters. Maybe what I want to do is actually start, because I don't want to have my heart broken, let me start with having a long lifespan. And then on top of that, maybe, I only want to limit myself to dogs that require minimal grooming. So you get the idea right away that one way of using Pivot is when you start off with many things, it's a quick way of drilling down to few things and then maybe even to one. And so we did that somewhat symbolically by acting on those filters on the left-hand side. This sort of mirrors the type of interaction that you do because we're built on top of Seadragon, where you can zoom in and zoom out and really pull up some amazing high-resolution detail from afar and drill all the way in. What you may notice right here is that we can get in so high on this one particular picture that we can see the photographer's reflection in the eye of the dog, which is, again, because of the Seadragon technology. The next example I'm going to show you is a completely different set of data. We're going to look at a set of data that comes from the game Magic: The Gathering. And I'm going to, again, like I mentioned before, the caveat with that I gave you earlier with the network bandwidth, I'm a little bit worried about that. So I'm going to switch over to a local collection. And here it is here. So with Magic: The Gathering, for those of you who aren't familiar with it, basically in Magic, it's a game that is based on cards. Cards have certain abilities and powers and attributes. And people collect cards and they trade them and they compete for cards. And so again, one can go and navigate over different sorts of data. Maybe, in fact, we might be interested in this one particular data site, Eventide. Drill into that. Perhaps I want to reorganize it by the subtype of the card. And maybe from there I want to drill in to spirit cards. And now we're going to do something a little bit different. I drill into one card, take a look at its different properties that it has right here, which are revealed in this meta pane. And then from here I can say, well, you know what? I really like this card. Let me see what this artist has done before. So by clicking on that, I've told Pivot that I want to use that item as effectively a portal to all the other items. I took its attribute and used that as a criteria by which to pull up other things. And I could do it on all of these different attributes. So I could say, well, I'm really interested in seeing tribal cards instead. And here's all the tribal cards. You get the idea. Yet a different type of collection. Oh, and I apologize. This is what's going on with the stuff that's coming over our shared bandwidth right now. It's not quite the performance that I would expect, so we'll occasionally be going back and forth between local and non-local stuff. So let me now bring up a collection from Sports Illustrated. I'm doing a race between local and non-local here. The network stuff is still having issues. So Sports Illustrated is a really compelling collection, and let me just show you something kind of fun. Right now, we're taking a look at every single magazine cover that Sports Illustrated has ever produced over their entire history. And we're looking at a time, so we can right away get a quick glance as to when they started doubling the number of issues. I can take a look at the ordering of our filters within this filter pane, and right away I know that they more often featured football than any other sport. I can even see what were some of the top most featured athletes of all time. But if I wanted to, let's just say, suppose, for example, I was interested in golf. Wanted to focus exclusively on golf. Again, I can filter on that. We've now narrowed down and we can see the relative sports coverage that's been provided to golf over the years. I could then go back and take a look at who are the most featured athletes, because now those are shown as a function of what's presently in view. So there's this really interesting interplay between data and metadata. The metadata is used as a filter so that you can narrow and winnow down to the items that you want to see. When you've done that operation of narrowing down, it informs also the metadata that would be visible. So here we're seeing that among golfers, Tiger Woods, Jack Nicholson, Arnold Palmer, those are the athletes that have been most featured. We can even go down and take a look at what are the events that are relevant to this. So we see golf, the Golf US Open, the Masters Tournament, and we could choose to cycle through all of these. And again, for all of these items, we can drill in and take a look at this, the covers in high resolution. If you haven't figured it out, one of the guiding principles of Pivot from a design point of view is the emphasis of always having a continuous experience. We're using multi-scale and C-Dragon and deep zoom technology to make the interaction smooth and continuous from one step to the next. We're trying to get away of cognitive disruptions or context switches. So switching gears a little bit. And again, I'm going to continue to do this little game that I'm playing of racing the my local content with my remote content. So you have to bear with me. All right, this is actually... No. All right, so we're already loaded up here. This we're doing with the remote content. Hopefully the network will improve. So what we're looking at right here is the top 500 actors as measured by AMG. And I am really interested, well, first of all, we can, just like I had said before, having the ability of taking a look at the forest and seeing the pattern within the trees, we can do the same thing here. We can see who, in fact, is sort of for this network of performers, who's at the center of the universe in terms of having the most co-stars. So up top, we have Anthony Hopkins, Michael Caine, Steve Buscemi, Susan Sarandon. I'm a huge Walken fan, so I can narrow this down to Walken's co-stars. Then, after making that filtering selection, I can take a look at what are the movies that they most frequently occurred in. So Walken had most of his famous co-stars in the movie Pulp Fiction. And here's who was in there. And so from here, we can say, okay, let's drill into John Travolta. And once we select that, we see Travolta's movies. And so we're really kind of navigating over two different types of networks here. A network of actors and the movies that they're in, and the movies and the cast that they're in. And so now, by drilling into this movie Face Off, we could take a look at who the cast was. So again, instead of having a sort of a fixed universe of objects, we've embedded a larger universe of content within it. And So you can see here's the cast of that movie. And we can continue this ad infinitum, going to say Nicolas Cage, and so on and so forth. I'll talk about that later. So right now, the data on that particular set was all coming from the web, but we'll explain that a little bit later. Final thing I'm going to show in this part of the demo will be sports, but I'm going to show you a different slant on sports. So right now, we're looking at every major league football player, and so we can slice and dice them by teams. We could take a look at them at the different height ranges. Maybe what we want to do is just take a look at the big dudes. So over 282 pounds, seems to be more tackles in that category. We drill into them and we can take a look. What's going on in this set is, remember we had this info pane over here where we were showing additional information about the one item in focus. Well, I'm also showing that there are other related pieces of content here. So as we pan around and take a look at different athletes, we see that, okay, so we're looking at the Buffalo Bills. There's also the New York Giants and also the Buffalo Sabres, which is a hockey team. And what we've done is we've cross-linked connections together that were actually separate sort of universes of information. So we might have football in one, baseball in another, hockey in a third, but we can link them together, stitch them together. And so by clicking on that, I'm now drilling into that particular hockey team. I can step back and take the whole of all hockey players. I can reorganize them and take a look at them by position. Maybe I want to take a look at the goaltenders, and in terms of the goaltenders, I'm interested in who are the small, tiny ones. And it's kind of surprising that there's a couple that are really small. And now we can also take a look at how much they make. They're in a rather tight range. If they all make $850,000, let's take off the height restriction. And now we see that the range goes from around $500,000 to $750 million. Here are the top earners in terms of hockey players. So you see, again, we maintain the ability of going from many things to few things to one things to seeing the patterns among them to going back and forth and being able to exploit all of that. So let's hit pause on the demo. I'm going to go back to the slides. And let's talk about, and before I, before we talk about the details, I want to give a quick shout out of thanks to all of our content partners who helped us assembling all the different content. They're listed here. So how did we do it? Technically, it's actually a pretty simple architecture, but I'm going to explain this in about 3 different chunks. First, we're going to talk about the basic application architecture of the client itself. We're going to go into some details around deep zoom items, deep zoom collections, and a form of XML that we refer to as collection XML. We'll then take a look at some design patterns for different types of architectures, and this will touch into the questions of where did the data come from. So the architecture at the basic level is we have a rich client. It's a .NET client, and it is on its own very interesting because it's .NET at the most fundamental layer. Embedded within that is Seadragon, and that's the technology for manipulating all of the different content at different scales. And then embedded within that is Trident. What I didn't show you before, and I'll just quickly reveal this right now, is that in addition to Pivot being able to surface just collections of things that are remotely hosted on the web, it also has the ability to view a single web page. And we'll talk more about that. And again, I have to apologize. This is a network problem, and because I'm loading a web page right now. So we'll go back. And I haven't cached the web locally, so I can't do anything about that. But so this will become important later on, but we actually host Trident inside of our application Pivot The reason being will be more made apparent a little bit later. But in a nutshell, from a user perspective, this allows us to give a smooth interaction as you go from a collection of things to one thing to, say, the web page that was backing behind it. Now, there's also a service or a back-end service that we've designed with this as well. And as you can see from the diagrams, it really is pretty simple. We have deep zoom collections and deep zoom items, which are the exact same format that is used within Silverlight and other related deep zoom products. We also might use a database or something else to generate this XML, but that's not strictly necessary. The important thing to keep in mind is that what is happening is all done over the web as it exists today. So all the communication is over HTTP. All of the content that we're retrieving is just done through GET over HTTP. And in most cases, the content that's being retrieved is nothing more than files being served by a web server. So those files are in the form of the deep zoom collections and the deep zoom items, and also the XML. And that's pretty much it. So it's pretty simplistic, pretty easy in terms of authoring. But to get into the basics, let's talk a little bit more about what these things are, deep zoom items and deep zoom collections. So the simplest thing to talk about is first the deep zoom items. And again, most of you had expressed that you were very familiar with deep zoom or Sea-Dragon. Just a quick refresher on what these things are. Sea-Dragon and deep zoom are basically technologies for taking big objects and slicing them up into more manageable chunks. The way we do that is we tile the underlying images so that one could, if you were zooming in on some narrow part of that image, you only have to retrieve the tile as opposed to the whole image. And so this is a technology that has been used many times over on, say, mapping services and things like that. Now, the interesting thing that we do with this is we aggregate this at different levels. So the biggest representation of any image, you have to slice into many tiles. The thumbnail itself might be a single tile. And what we refer to as the pyramid is the structure at all the intermediate levels. The wonderful thing about formatting the data in this way is that it makes the experience of retrieving content a function of the number of pixels on your screen and the bandwidth that you have available, and not the size of the object. Because as long as you cap the size of the viewport, then the number of tiles that you have to retrieve at any time is always going to be a constant. You need to get the one that you're centered on and maybe the neighbors, and that's it. An obvious question in terms of what sort of overhead does this incur? Well, it's only about a 40% extra bit of overhead to the whole representation of the images, so it's not that expensive. The format for how you represent this is really embarrassingly simple. We have a simple XML manifest that specifies some of the properties of the tiles. They might be JPEG, they might be PNG, they might be something else, and what the width and the height is of the whole object. And from that, the tiles themselves are hierarchically stored on files in the file system. And so that is the whole structure. It's very simple. Anyone could actually produce it. We also have a number of tools that have been around for a couple of years now for simplifying the process of creating deep zoom items. A deep zoom collection is the same idea, but applied to many things instead of just one thing. And so what we do for a deep zoom collection is we effectively concatenate a representation of all the individual items into one item, which is what you're seeing here, and then apply the same sort of multi-scale representation to it, creating sparser and sparser representations where it has to be tiled, but then we eventually all the way go up to the thumbnail of the collection as well. Now, because we have metadata around what the individual size and dimensions are of the tiles, that means that when we load a collection, it is very inexpensive to load the collection. It's effectively the same cost as loading one image and the XML. And from those 2 bits of information, we have everything that we need in order to create the illusion that you are interacting with thousands of things at once. The XML for this is similarly straightforward, but now instead of just talking about the properties of one item, we are enumerating the properties of multiple items that are inside of the collection. So you see here we can assign an ID, other things in terms of the path to the underlying DZI, and what is its width and height. Collection XML or CXML is one thing that we're introducing today that hasn't appeared elsewhere. The deep zoom stuff has been around for a couple of years now and is well established and part of the expression toolset, as well as Silverlight. The collection MXL is responsible for specifying how visual assets, visual data, is connected to the metadata in that facet pane, as well as the metadata that's in that info pane. And so what we have right here is a slight stylized representation of what that would look like. So if these red squares down on the bottoms are my items that are on the page, and I have a certain number of facet categories. Maybe these items here are shoes, and my high-level facet categories are size and color. Then these blue facets might be size 10, 11, and 12, and the facet categories over here for color might be red and blue. And so then these edges that span from blue items to red items are nothing more than affinities between a property and an item. So this is a way of saying that this item, say the one over here, happens to be blue and is a size 12. And with this simple representation, it's pretty, it's fairly application neutral. We're not designing a schema that's application specific to any one application. It's sort of like the least common denominator schema for many applications. The XML for this, I'm going to have to show it in two parts, but basically it's still pretty simple. We start off by enumerating what our facet categories are. So in this example, I'm imagining a situation in which we have facet categories that are describing people. So one facet category would be the nickname, their weight, their birthday. And then within the XML, I have a reference pointing to a source DZC for the underlying visual assets. Once that's done, I can then enumerate what are effectively property value pairs between my facet categories and my items. So here for one item, which has the name of Alice, and we can assign a URL to Alice as well, and a description. We say that Alice's nickname has the value of Ali. Her weight is 123, and her birth date has this date value. And we support a couple of data types to surface different sorts of experiences. Like you may have noticed that for numerical values, I was using a slider at some point, and for textual values, I was clicking on facets themselves. The final thing to talk about is the design patterns that we had shown you. So the first design pattern is the simplest, and we refer to this as a simple collection. It's something that scales up to around 5,000 items. So with a simple collection, what you're doing is that you're defining a DZC for the collection, all the visual assets. You're defining the CXML for that collection, and that's pretty much it. These are files that are hosted at a web server, and from that you can access both the metadata and the data pretty simplistically. There's no database. There's no real sophisticated backend at all. It's very simple, straightforward stuff. The dog breeds and the Sports Illustrated covers fit this design pattern. The next design pattern takes this just one step further, and we saw this when we were looking at the movies collection as well as the pro sports as surfaced through the NFL and the basketball and hockey. And what we do here is we basically define multiple simple collections, but instead of treating them as isolated islands from one another, they are effectively stitched together. So this is a way, or linked together. So this is a way for us to get around a technical limitation and hiding some of the details from the user in a way that just makes this scale more simplistically. So again, for the concrete examples of the pro sports, one of these red blobs corresponds to all of pro football. Another one of the red blobs corresponds to all of pro baseball. and so on and so forth. It was the related links that we showed between them, where we were allowing someone to go from a Florida football team to a Florida baseball team that represents these arrows between the different sets. And so this is, again, a simple way of potentially coming up with a solution that is larger than what you would ever want to show at once, but can scale in an unbounded way. The static architecture might make use, will look a little bit like this. So we have a web server, we have some, the DZCs and the CXML that we have to reference, and we're hosting these DZIs as individual blobs, basically. And that's it. It's pretty simple. So with that, it actually serves as a good segue to go to the next kind of second half of the demo. And during that time, we actually succeeded in loading up a web page. All right, so you can see this is just a web page here, nothing special. I told you before that one reason why we hosted Trident inside of this application to give that continuity was so that we would have that seamless experience of going from an item in a collection to a backing web page. And we also try to take multi-scale very seriously so that we can do things like bringing multi-scale interactions even to looking at one item like a web page. So and what you saw there was just one example of that. Now, I alluded before, a little bit earlier, I said that we had another reason for adding collections. And what I'm going to talk about now in the next examples are what we call dynamic collections. And I'm going to show you two different types of dynamic collections. One that is constructed implicitly and locally on the client machine, and another set of another dynamic collection that is hosted externally. If one of the reasons why introducing an experiment like Pivot is a little bit challenging is that you have a chicken and the egg problem. So for example, we want to make something that is a compelling experience for looking at collections, but in advance of there being lots of collections, the value proposition for someone to actually try this out might be a little bit minimal. So what we did was we thought long and hard, what would be a way for users of this little application to be able to quickly and effortlessly build up a collection that was personally meaningful to them. And so the simplest way of doing that is to plug it into your browsing history. So what we've done is precisely that. We've taken the whole task of making sense of your browse history in exactly the same form. So what you can do is you can take a look at all of the different steps that I had done here over the course of this demo. We can go back and take a look at other points in time. Maybe it looks like I was busy doing a lot of browsing here, a little searching at Bing, so on and so forth. And you get the idea. And we can use the exact same navigational metaphors that we used earlier. I could go ahead and I can filter based on, say, the domain name and take a look at all the Bing search results that I'd been at earlier. Or maybe what I want to do is I want to take a look at what the groupings are of search terms that I actually gave at another time. So if I organize over search history, turn off the filter, I can take a look at all the different queries that I had done at different times. So at one of them was where to eat. And so and this is just a quick way of sort of building a collection that has some value and relevance to you. Now, keeping that, and we do the same thing for tags as well. So for example, I could go back and perhaps I was researching for dogs at one point or blogs that I had tagged. Again, it's a consistent way of navigating and making sense of collections of things. Now, with this segue, I'm now going to go and, network gods permitting, I'm just going to pull up a Bing search result. I'm going to type in something else over here. I'll type in Einstein. Okay, so it looks like networking is being kind. Ooh. Okay. So again, we have the Bing search result. Nothing too surprising here. What you may not have noticed, that in this area over here, a little hint came up. It says explore Albert Einstein articles. So if I click on that, what that's going to do is pull up a dynamic collection that is being assembled on the fly, basically. And so what we're looking at right here is the collection or representation of all the different concepts that relate to Albert Einstein at Wikipedia that link off of Albert Einstein's page. So we have all of these different concepts and people, and they're represented by these little trade cards. And if we wanted to, we could learn a lot of information just from this view. So for example, imagine you knew nothing about Albert Einstein at all. Well, we could take a look right away on this facet pane to see that the things that are most prominent about Albert Einstein is something about fundamental physics concepts. So we can do that, and we see general relativity. We can see that Albert Einstein has some relationship to Nobel laureates in physics. We can see that he is one of many Jewish scientists. Or we can see that he, at a more granular level, is a relativist. And so again, this is an example of the forest revealing some patterns and us being able to quickly navigate those things. Any one of these different cards of Wikipedia, we could double-click on it, and dynamically, it is generating the CXML and the DZCs required to view these items again. And so I just double-clicked on general relativity, and once again, we see that fundamental physics concepts are very prominent. We can go in and drill in on the cards themselves and see all the different lower level things that are there, and again, drill in again. And the thing that I haven't stated explicitly, but I hope it's been a little bit more obvious, is that we've done this for the whole of Wikipedia, and we're dynamically generating this stuff at query time. So instead of limiting to ourselves to a simple collection that can only be, say, 5,000 items, or a group of linked collections that might be tens of thousands, we're now doing something that's in the millions. And again, we're going to talk about that architecture that makes this possible shortly. So one thing that I want to do before we leave this set is I want to go back and show you something of a high-level view of Wikipedia. So, and this is just kind of fun. What we're looking at right here are the most 500 popular concepts by traffic and interest and link that appear on Wikipedia. And what's interesting is that there's information that you can see in this set that is not visible in any one Wikipedia page. So, for example, one of the most prominent things that's researched on Wikipedia are American universities. There's also liberal democracies and Time Magazine's People of the Year. And again, for all these concepts, we can go ahead and double-click on any one of them to see the set of concepts that emanate from them, in the sense that they are pages that link off of Wikipedia. And again, I want to apologize. Your experience on navigating this when you go home will be much better than what it is here because of the issues that we're having with sharing bandwidth with everyone else in the conference. So, back to slides. Dynamic collections are, as I mentioned before, conceivably unbounded in size, and what we do is we split apart the metadata into different parts, as well as all the visual assets. The cleverness to this architecture that makes this possible is that we do what's effectively a split between things that must be calculated in advance versus things that must be calculated at query time. Let me explain. Our architecture starts off with having pre-built all of the items that you saw in advance. So the card for Albert Einstein, the card for relativity, the card for all these different things was pre-built in terms of the DZIs. if a query comes in, what we do is we hit a database that has data about the different collections and how they're stitched together, stored effectively in RAM, and we use that to dynamically generate the CXML that is appropriate for that particular query, as well as the DZC, which is the if you will, the contact sheet of all the different cards. The DZIs, though, have already been pre-built. And if you take a look, what we're effectively doing is, if all of this file server represents the whole of all of the items that have been pre-calculated, all 2.5 million, and these red circled ones are merely the ones that have been that are part of this result set, then what we're doing is we're effectively just making references in the DZC to those items and nothing more. We don't have to actually generate them. It's just a matter of inserting a URI into XML. And so what this means is that if there was another query, hold on a second, if there was another query that came along, we might actually end up with a completely different set of red DZIs that are referenced. But we don't have to pre-calculate them again. Again, we're only calculating or producing the CXML and the DZCs at query time. So putting all this back together, I again want to emphasize and remind you of the point that despite the appearance of this being something of a rich application that's operating over the web, which sometimes implies that there are different sorts of protocols and file formats and other things being used, in a lot of ways, we're very much backward compatible with the old web as well as the existing web, in that we're just using HTTP GETs serving files over a web server. It's that simple. The schema that we're using is fairly application neutral, in that the only assumption that we make is that you can represent what it is that you're interested in terms of attribute value pairs. So we have the facet categories and the individual facets. I say this with a little bit of tongue in cheek that this allows for compelling scenarios to be realized without any code. Of course, you have to write some code if it's only even an XSLT for doing the transformation. But suffice it to say that you can produce really compelling things with nothing more than just assembling the assets and the XML. If one were to take this a step further and imagine embodying some element of logic within, say, a proxy layer with this sort of dynamic architecture, then the possibilities for what you could do are actually quite endless and profound, because you won't be limited by what is already pre-calculated or what one could compute offline. You might actually be able to make something that is that goes well beyond what could be encoded within the application. So the exciting thing to announce today is that we're making Pivot available to everyone. So just a quick show of hands. We can only give out 100 copies. Who wants them? Okay. Actually, I'm joking. Everyone gets a copy. But it's nice to see all the hands go up. So we'll be, at the end of the show, I want you to look for the nice people with the big bags of cards. We're going to give you one of these cards. It has a little scratch-off thing. Underneath the scratch thing will be a code. That code will help you, will allow you to do an install. You go to www.getpivot.com, and at that site, you'll get the client bits. You'll get access to all the collections and more that I showed you here. There's a whole bunch of white papers describing all the technical details for how we built everything that we built. And we even have a quick and dirty little tool for authoring collections that is basically an Excel plugin where you do nothing more than list URLs, items, and property value pairs within columns on a spreadsheet. Press a button and it builds the collection for you. So there's all the tools that you would need to get started to start building your own collections. Now, in return for this, we want you to surprise us. And we're going to quickly iterate on Pivot. It is an experiment, so we're going to, in the near term, add more features and more capabilities. But what we really want to see is when we push this out to you, the developers, what you can make of it. So just some ideas to kind of throw out there. without tapping into the low-level code of Pivot the application, one could imagine writing a proxy server that basically intermediates between Pivot and, say, desktop search, or Pivot and SharePoint. Or you might do something with all the publicly available government data that is existing, or any existing online services, biology, human genome data, the Internet Archive. One thing that I want to make a very special push for is Dallas, our special project that was announced by both Ray and Dave Campbell that is taking lots of complicated and structured data and putting uniform APIs on top of it. So there's really great mashup opportunities for taking data from Dallas and visualizing it within Pivot, and we would really love if you can surprise us with that sort of thing. To kind of wrap things up, one thing I want to call out is that, from a personal note, I've been working in web search for just about 10 years now in terms of thinking about what web search is and what it can become. And to be perfectly honest, I still don't know that I know even what web search is. Because when you think about all the different ways that people interact with data, we do a couple of different modes of things. We like to look at, say, we might have the mode of, I'm considering thousands of objects at once, and I really am looking for the needle in the haystack, so I need to drill into one thing. Or we might be in more of a browsing mode where we're going from one item to the next, following a series of links. Or maybe we're doing something that's about exploring things in a more serendipitous way. Say if I was at an e-commerce site like Amazon or iTunes, where I'm really looking for recommendations that are based on other preferences or actions I've expressed in the past. Well, what we're trying to do is come up with something that really sits at the intersection of all these things. Because right now, these are very different modes, and we happen to think that if you could blur the lines between these different modes, you could actually reap lots of rewards for the user in terms of what their ability is to make sense of vast quantities of data. And our goal is modest, but we're modestly stated, but kind of big in aspirations, and that is we want to do a little bit better by unifying these different modes. Another way of sort of thinking about this whole thing is to think about how the web exists today. And my claim is that Pivot in some ways reflects an inversion or perhaps turning the web upside down in some way. So the web experience that we're all familiar with versus the Pivot experience has some really interesting comparisons. In the web experience, you're looking at only one thing at a time, whereas Pivot, the soul of the application is really about looking at many things at once in a multitude of ways. We also differentiate the web experience from the Pivot experience in that navigation consists of going on the web from one thing to the next, whereas navigation and Pivot goes from many things to one thing, from one thing to many things, and everything in between. The relations on the web are embedded within one item, whereas relations for us sit above the pool of content. They become really visible, really actionable when you can actually see them from afar. And finally, the experience is instead of reading a document where you're iteratively going from one thing to the next, we're really more about swimming through content in a way that, as I stated up front, we hope is both informative, joyful, and powerful. So whereas I started my presentation talking about the difference between data, information, knowledge, and wisdom, we have lots of data, little wisdom. Pivot isn't the answer, but we hope it's the start of a conversation for how we, as technologists and as a society, can get a little bit closer and climb that ladder and get to the better parts. So with that, I thank you. So we've left 10 minutes for Q&A, which we're pretty much right on schedule with that. One thing before we go into Q&A, I want to make a special request. As some of you, people have already been telling you already, please make an effort to evaluate not just this session, but all the sessions. Every time you do an evaluation, $1 goes to charity, and it helps us to inform how to make PDC better. So please take a few moments and evaluate this session and other sessions. So with that, let's take some questions. And I'd ask also that I'd want to direct you to the microphone. So we have someone right over there first.
Hi,
Yes.
I had a question about when you were displaying the hockey players.
Yeah.
And the weights and the salaries.
Yeah.
How many steps would it be, or is it possible at all to get from those two different pieces of data to a graph of weights versus salaries? Is that possible? Like in Wolfram Alpha. And
yeah.
My follow-up question is there any relationship between what you're doing here in your CXML and the way that Wolfram Alpha organizes its information?
So let me answer the second question first. There's absolutely no relationship. It's just kind of a coincidence. We've been sort of pursuing two different efforts without even any real communication. I know Stephen, but we never compared notes really on this. In answer of your second question, one thing that we are going to be iterating on very soon is the number of different views that are available in the application. So you only saw two views today. One was the grid view, the other was the histogram view. One thing that we've prototyped but we didn't put it into the shipping version is something that we call comparison view. It's basically a 2D histogram where you could basically take one attribute and another attribute and get a density plot in terms of those attributes. So you can actually see how weight corresponds to salary and all those other things. But we cut it in favor of hitting this date today. Yes?
I have two questions.
Sure.
First question, do you have any plans for a mobile or an iPhone client?
Short answer is no. It took us quite a while to actually get this running on one platform, and our focus is going to be keeping it on that one platform so that instead of going broad and keeping the same set of features, we want to iterate and keep adding features to figure these things out. It's a little bit more of an experimental strategy. If this was on something more of a product strategy, that might make sense for us, but it doesn't.
And then second question, is there any plan for an MDX type connector to any standard data warehouse or cube?
So we haven't made any standard connectors, but that's something that I'm certain will emerge either from third parties or if this is the sort of thing that actually has some legs in it, I think a lot of people will innovate in the space of figuring out how to get more things into Pivot.
So, thanks.
Sure. Yeah. Again, I'd ask you to go to the microphone if you have a question. Yeah. So, over here.
Oh, hi, yes. I actually have two questions. One is, do you have like an OR semantics for the language? It looks like an AND type semantics right now.
That was very astute of you to notice that. So we have implied OR within a facet group and implied AND across facet groups.
Okay. And the other question I have is, are there any plans to get the industry to adopt your mechanism, your process for generating the DZIs, either as part of a specification or whatever, to propagate it throughout the industry?
Yeah. So let me answer that in two parts. Again, I want to emphasize that Pivot is an experiment, so we have no plans for industry standardization efforts, at this time. It's just really premature for that. I will say, though, that half of that format is part of Deep Zoom and part of Silverlight. So the answer is, to the extent that Silverlight and its file formats and the things that it's part of will be making use of those mechanisms, then yes, Deep Zoom might fold into that, but it'll be a side effect of that more formal product effort.
Thank you.
Sure. Yes?
So say I want to make a collection of all the pictures of my family over 50 years.
Yeah.
And so if I just have a bunch of raw pictures, raw image files, I would have to go through and create the property value pairs for every picture, and then I could take that collection, or I guess that's creating a Deep Zoom item for each image. Is that correct?
It all depends on if they exist already. If the problem is that the property value pairs don't exist,
Right.
then yeah, they have to be created. But if they do exist in some format and you can programmatically get them in a spreadsheet, tag of person equals whatever in a column on a spreadsheet, then with the tools that we're releasing today, you'll be able to create a deep zoom, a collection for that.
Okay, thanks.
So, why don't we go back over here?
While creating the dynamic collections, how do you handle the redundancy or recursion?
I'm sorry, I couldn't hear that.
How do you handle the recursion or redundancy in data?
The same way the web does. So, and what I mean is, if I understand the question, if you have recursion in the data, well, that's reflected by a cycle in the graph of hyperlinks. And so we can have a cycle in the cross-linking between collections as well. In fact, we do. So if I did understand your question, that's the answer.
How about the redundancy? I mean, you have a single source but multiple links to it. Do you show
the
them?
redundancy is gracefully handled. So for example, the Wikipedia example is a perfect example. We have 2.5, on that order of magnitude, individual cards that represent one Wikipedia page. However, all the different queries, all the different ways of slicing and dicing that data. So for example, if I was looking at Time Magazine People of the Year, I could click on US presidents or whatever. All of those different slices are making reference to the exact same pool of 2.5 million DZIs. They're shared basically across all aggregations. So the redundancy is perfectly handled in that sense. Yes?
Hi, with C-Dragon visualization and all that categorization, aggregation in search you just showed us, it's a really cool feature. But what I'm still missing in search, in this tons of information which is currently on the web, I want to ask you if you're thinking on that too, is to track some patterns, relationship between the source of information and followers and how the information passes on in pretty nice visual ways. Is something you're also thinking on?
I'm sorry, can you repeat the second question, the second part? I was getting ready to answer the first part, but go ahead.
Okay, feature I'm looking for is in pretty nice visual way track information. What is the source of information and what is just the source of information and followers. Because we have plenty of information which just follows some source, with sometimes not adding little value, sometimes adding some local comments. I'm interested to see visual ways how that information passes on the internet. I'm thinking that something like that also could be used there. So this is feature I haven't seen anywhere, but I'm just curious if you're thinking of something like that, in that direction.
Yeah, I have to admit, I'm still not understanding the second part of the question, and I don't know if it's. I think I'm just not parsing something correctly, but are you asking about derivative data, or a kind of, I don't know. I'm sorry, I apologize for that. Let me answer your first question, which was around search. So one thing that we can do is, and I didn't really have time to show this, but we actually do have search supported within this as well. And so, and again, that's a network issue right there. I can quickly search across a collection. I could go back and take a look at, say, my history and do two different things that are related to search. I can start typing in things, and you can see right away it starts completing over valid things here. I can filter over purdue.edu, or I could even go and take a look at what were some of the searches that I had done on other search engines, because we implicitly tag over that information as well. So we are thinking about how to integrate this with search in different ways. We work closely with the search team. So,
okay.
Yeah, thanks. Yep. And I see that we're out of time, and they're giving me the sign to cut it off, so I'll walk with you, and we'll take it offline. Thank you again, everyone.